Good morning, good afternoon, good evening. Welcome everybody to today's session, Cloudera Altus, massive scale machine learning analytics service in the cloud. Today, we are going to explore how data engineers and ETL developers can simplify the process of running and troubleshooting their workloads in the cloud, how data analysts can leverage Cloudera Altus data warehouse to run queries at scale without compromising on response times, and how architects and administrators can leverage Cloudera Altus Director to provision customized Cloudera clusters on Microsoft Azure, AWS, and Google Cloud Platform. We will also showcase a Cloudera Altus-based solution delivered jointly by Ultra Tenancy and T-Systems to large, highly regulated enterprises. Our speakers today, Dr. Robert Neumann, CEO and Principal Big Data Solution Architect Lead at Ultra Tenancy, and Michael Koos, Technical Marketing Manager for Cloudera's cloud product at Cloudera. A few logistics before we get started. In case you have any questions, please submit them via text chat as we go, and Robert and Michael will answer them at the end of the session. And this session is going to be recorded, and we will send out the URL within the next 48 hours. Without further ado, let me hand over to Michael and Robert. Guys, the stage is yours.
Thank you very much, Rafa. Hi, everyone. Good morning, good afternoon. This is Michael Koos speaking. I'm a technical marketing manager for Cloudera's cloud product at Cloudera, and looking forward to have the opportunity to talk to you about our Cloudera Altus components in the next 30 minutes. And then I'll hand over to Robert. Robert, maybe you want to quickly introduce yourself as well.
Sure thing. Hi, this is Robert. I'm Big Data Solutions Architect at Ultra Tenancy. We have worked with Cloudera on integrating Altus into a new T-Systems product that is called Data Intelligence Hub. It's going to be released soon, and I'll tell you the details and the reasons for why we decided to go with Altus in Data Intelligence Hub.
Perfect. Thank you very much. So let's get this started. And a good way to start is usually to give a few examples of use cases and companies that are using Cloudera's products to implement new business solutions. And I've just picked out 3 of our customers that we can talk publicly about. We usually categorize companies that implement Cloudera solutions into 3 different areas. So they either build a solution to drive customer insights, build better profiles of their clients, or they are in the business of IoT. They want to do predictive maintenance and connect products and services, or their solution is all about protecting the business by reducing fraudulent transactions, for example, or by analyzing internal company networks and finding out if unusual activity is happening and to identify hacks before they can be really malicious for the company. So some of the example companies here is BT, British Telecom in the UK. They are using Cloudera heavily to build 360 profiles of their customers, of the subscription customers, and the main use case is to reduce the churn of their individual customers by targeting them better based on their usage patterns. Navistar is a US-based truck company that uses our services heavily to improve their maintenance of their truck fleet. So they had the issue that maintenance costs were a big portion of their operating costs, and they had to bring them down in order to compete better in the market. They built a solution with Cloudera to proactively analyze the truck sensors and the truck data to automatically create routes and plan routes in a way that the trucks would stop at certain shops to be serviced before they actually break down. So Navistar managed to reduce the service cost dramatically. And the last example here is MasterCard, who uses Cloudera products to identify fraudulent card transactions. So Cloudera delivers to those companies and to everyone else a modern platform for machine learning and analytics optimized for the cloud. So we make sure our platform that you can build all those use cases on is enterprise grade, That means it's secure, it's performant, and it's compliant to all the tests that enterprises have to comply with. It has to be very scalable because we are working with the largest organizations on the world. So our platform has to be elastic, it has to be able to grow, has to be very cost effective, and overall has to provide a low TCO for our customers. And it also runs anywhere. Nowadays, this is really important. We have a lot of customers that are running on-premise with our data platform, but nowadays, many organizations are shifting to the cloud. They're running hybrid environments, so our platform has to run anywhere. Our platform is built, in the center of our platform is what we call the Cloudera Shared Data Experience, which is an environment that shares all components that are required to make a platform enterprise ready and enterprise grade. So we have our security products in there, components that take care of governance and lifecycle management, as well as providing a centralized data catalog to all the different use cases that we can build on top of that platform. So usually our customers build data engineering solutions, data warehouse solutions, data science solutions, or operational databases on top of our platform. And Cloudera Shared Data Experience makes sure that no matter which service you take and implement, the user experience is always the same. You only define security once in this shared data experience layer, and then all your additional use cases will benefit from those security definitions. The algorithms that run or the workloads that run, they can access data stored in different storage systems. We can work with HDFS, that's our traditional storage system, being a Hadoop platform, but we can also work with Apache Kudu, we can work with Microsoft Azure Data Lake Store in the cloud, and with Amazon S3 object stores in the cloud as well. So our platform is really flexible, the center, the shared data experience that enables all those different services to play nicely into each other. So let's quickly review what happened in the last couple of years and why customers are moving their data platforms to the cloud. So if we go 5 to 10 years back and look at our Cloudera customers, then usually what we would find is a large on-premise cluster that serves multiple tenants and multiple workloads. All those tenants are isolated by different security rules, by different workload management settings, but they can still all access the same metadata, the same data, because they're running on one large shared physical cluster. Now, if you imagine large organizations that have hundreds of business units and hundreds of tenants, you can get an idea of the complexity and the dependencies that you will find in such a big platform. So while those platforms are very good in terms of economics, you really use the platform almost to 100% because you have so many tenants working on the platform. It can get really complex to manage, and it can also be very slow to grow or expand. So if you have 100 tenants on the platform, and imagine you now have to do an update, or you want to grow your cluster, you have to order new physical servers, and this can take months for some organizations until those servers are available. Therefore, what happened, this was frustrating to some business departments, and they actually looked at public cloud vendors that promised to make things easier and promised to make things faster for them. Because of that, individual departments were now moving to the cloud and implementing their individual use case on cloud-based data platforms, but they only cared about their own use case. So they did not care about building up a shared data experience, a shared data context, sharing metadata with other workloads. They mainly cared about their own workload. They wanted flexibility, agility, to be able to grow it quickly, and then access data that's stored in S3 or Azure Data Lake Store. So while that's great for flexibility and speed, on the other hand, it created a lot of individual silos that still stored their data context within the individual clusters. So there's no sharing of any metadata here with a cluster from another business unit. And if you destroy one of those clusters, your metadata is also being destroyed unless you actively take care of that. So again, provides great flexibility, speed, agility, but really is not the same experience that customers and operations teams are also used to from Cloudera on-premise. Now, what we did to solve that issue is introduce SDX, the shared data experience, also for our cloud deployments. And we basically put in another abstraction layer in between the raw shared data in S3 or Azure Data Lake Store and the individual workload clusters. So now, for example, data context like Hive tables are being stored in a centralized repository that all those different workloads clusters can connect to, and then automatically register the existing databases and tables and connect to the raw data underlying those tables. So with that architecture, we can now bring together the flexibility and agility that we get from public cloud providers, because individual business users can still create their own clusters very easily, but also bring the benefits of our multi-tenant on-premise clusters to this new environment by offering the shared data experience also in the cloud. And this is our architecture in the cloud that all of our customers can benefit from. So when we now really look at cloud and how can we deploy our Cloudera data management platform in the cloud, there are two different possibilities. Number one is we use infrastructure as a service from the public cloud providers, Microsoft Azure, AWS, or Google Cloud Platform. And we use Altus Director to create a new Cloudera cluster, connect it to an SDX namespace, and make sure we can share the data between different clusters. With that approach, users would still have to manage a piece of software, which is Altus Director, but on the other hand, they get the full customization and full configuration options that they know from our platform. Now, the other option is to use our Altus Cloud Services, where we offer platform as a service offerings targeted at different specific workloads and use cases, and where we take care of things like cluster administration, cluster management, operating system patching. So there is really, the experience is much better from a user perspective, and there is less operational overhead when you go with the cloud services. The actual offerings that we have available as of now with Cloudera Altus are, as I said, the Cloudera Altus Cloud Services, Altus Data Engineering, and Altus Data Warehouse, and Altus SDX. So all of those services are hosted by Cloudera, and we offer them as a service to our customers for specific workloads. Altus Data Engineering, for example, is great when you want to run Apache Spark, Apache Hive, or MapReduce jobs to do large-scale data processing in a batch-oriented way. We will give you an API to submit your jobs to, and you can run your jobs easily on a cluster that we provision, we manage, and you don't have to worry about any of that. With Altus Data Warehouse, we offer similar functionality to data analysts that want to work with SQL and analyze their data sets stored in S3 or ADLS. We offer a built-in SQL editor for users to do ad hoc data exploration, and they can also expose an endpoint from those Altus Data Warehouse clusters to connect BI tools like Tableau, Qlik, etc. to their clusters and analyze the data just as they're used to. And then finally, Altus SDX is, as I said before, a PaaS offering, and that manages data catalog information. So we host an Apache Hive Metastore and an Apache Sentry database that you can connect your clusters to. And in that centralized Metastore, we will store table information and access policy settings in Apache Sentry and make sure that Altus Data Engineering and Data Warehouse clusters can seamlessly share that metadata between each other. And last but not least, Altus Director is the option if any of those workload-specific cloud services might not fit for your workload. Because with Altus Director, you get the full power, the full breadth of our platform, and you can take care of all the configuration settings that you need to in order to support your use case. So with Altus Director, we also support Apache Kafka, we support Spark Streaming, and our data science workbench. And with Altus Director, you can also deploy your clusters on Google Cloud Platform. Let's have a quick look at the Altus Cloud Service architecture. So we, as I said before, we are hosting those cloud services, and we are hosting, for example, the user interface. We are hosting an API, and we're the whole service that manages the job queues and does the workload analytics. So a user logs into our user interface and then creates a cluster, but we only orchestrate the creation of the cluster in a customer cloud account. So this is a key design principle here, that we don't create clusters, no matter if it's a data engineering or data warehouse cluster, in our Cloudera account. We will always create them in the customer's cloud account, so the customer stays in control of all the data, of all the clusters, and there is no actual data being exchanged between the Cloudera Altus Cloud Services and the customer's cloud account. If a customer wants to, they can activate this workload analytics section, and then we will collect some usage and log information about the jobs that are being executed for a better analysis of the job performance and errors that might have occurred during job execution. But the key point is really compute clusters are being always created in the customer account, and they directly connect to the object storage also in the customer cloud account. For data warehouse clusters, very similar picture. There are two ways an BI analyst can interact with those clusters, either through the web and using the query editor, or using third-party BI tools like Tableau, Qlik, etc., and then just use our Apache Impala ODBC driver to connect to that cluster. And then again, the clusters will directly access the object stores in the customer's cloud accounts. Okay, so how do our customers typically build up data lakes or data management platforms in the cloud? So even though they tend to use object stores like Azure Data Lake Store or S3 as a centralized storage layer, they still create logical zones, is usually what we see. So there might be a landing zone, there might be sandbox environments for data scientists and data analysts, and there might be a consumption area for refined data sets that your typical BI analysts with external tools can access. So we can use Altus SDX to share metadata for all those different environments in a centralized way, and then make sure that data engineering clusters that, for example, take data from the raw source area, transform it, and write it to the sandbox environment or to the consumption area, can store the result of those tables or new tables in the centralized SDX store, so that other clusters, like this Altus Data Warehouse cluster here, can use that data, and the data analysts can directly work with that data. And as I said, the final interaction point usually is that BI users work in that consumption area. Okay, so let's quickly jump into a demo of Cloudera Altus. There's a little demo scenario where we're analyzing taxi data from the New York City taxi authorities. And actually, our role is going to be a data analyst. We're working for Dinner Time, which is a chain of restaurants, and they're about to open up new restaurants and want to market them efficiently. And we are about to find out if we can use the New York City taxi data to identify potential locations for our billboards. So we have a few technical issues. One of them is our production data warehouse cannot take any additional load without affecting the production SLAs. So we can't use our production data warehouse to do our ad hoc analysis here. And all our raw data is stored in an object store. So we need a data warehouse environment that can access that object store. And we also need a separate data engineering environment where we can transform data and create our own sandbox so that we can really work with our own data set. And in order for all of that to work together, we need the ability to store metadata in a central data lake. So we're going to see now, we have trip data stored in a source database from yellow taxis, green taxis, and the different taxi zones. We're going to use a job in Altus Data Engineering to create a summary of those trips. And then we're using Altus Data Warehouse to analyze those trips and produce the result for our use case. So let me switch to my browser. And the first thing that I'm going to do is, so I've been given access to our data lake by getting access to a specific namespace. In that namespace, we have created the source database and our source tables are present in that namespace. So this is called NYC Taxi Data Azure. In there are all our tables. First thing I'm going to do now is create a data warehouse cluster because I want to be able to do ad hoc exploratory analysis of the data without affecting any production workloads. So I need my own compute environment. I'm going to give that a name, latest CDH version, the namespace, and I'm going to select an environment where I will deploy this cluster in. So this is an environment in Microsoft Azure. I can specify the number of compute nodes, set Cloudera Manager username, password, upload an SSH file, and that's all I need to create a cluster. A few minutes later, this cluster will be ready and I can use it for my analysis. So for this demo, I've already created a cluster that we can use to analyze the data. And as you can see, it's connected to the same SDX namespace. So therefore, the same tables are available to that cluster. So in order to work with that data, I'm now going to open up the query editor. And now within the Altus console, we'll have the opportunity to work with our data without having to install any third-party tools or figure out how to connect to this cluster. But it's really built into the product and makes it very easy to use. So I have this source database here, the NYC Taxi Landing, and I can look at the tables that exist in there. So I see the green trip data, yellow trip data, etc. Let's just have a look at the data in the green trip data table. Limit that. And now I'm executing a query that uses metadata stored in a SDX namespace to access data that is stored in Azure Data Lake Store. So our Impala cluster, Altus Data Warehouse cluster, is now directly accessing data on Azure Data Lake Store. And I can see very detailed very detailed items here of individual trips, how many passengers rode the taxi, etc. What was the fare amount, etc. That's all great, but that might be too much for my use case because I'm mainly interested in the busiest drop-off and pick-up locations. So I would like to have some aggregated views of all those trips together and then grouped by the drop-off zone because that's a potential good location for my billboards. So what we're going to do now is we're going to go to Altus Data Engineering and we are going to submit ETL jobs that are going to create those aggregated tables for us. This will run on a separate cluster, separate environment, so it will not interfere with whatever we are doing in our exploration cluster or whatever is happening on the production cluster. So I'll now submit a single job. It's going to be a Hive job, and this is going to be summarized by drop-off zone. And I'm just going to use that script. I have to use 2 parameters for my database, just meetup demo, and my data lake folder, which is also meetup demo. And then I can select if I want to execute that on an existing cluster or if I want to create a new cluster. I will execute that on an existing data engineering cluster, which is a Hive on Spark cluster. And this will be used now to execute that query. While this is executing, we can just have a closer look at what actually is happening in that script. So we are creating an external table, specifying all the fields that we want to see later on. And we're storing it as a Parquet file in this location. So we're storing it pointing directly to Azure Data Lake Store. Now the actual ETL work is happening here, where we're inserting into that table that we just created, and we select the data from the taxi trips with all zones. We calculate the sum of all trips, the sum of the fare amount. So we do a lot of calculations here, and then we group everything by the drop-off zone, so I can later see which is the busiest drop-off zone. Once those jobs are complete, you can actually use Workload Analytics that I briefly mentioned before to get a better understanding of what is happening in those jobs. So once a job completes, you get this analytics view, and this helps you to understand how your job performed and if there are any opportunities for optimization. So this job completed successfully, completed fine, but Workload Analytics identified that there might be an issue because it processed an abnormal amount of data. So there were some previous runs where we read 2 gigabytes of data, then there were some where we read only a few kilobytes of data and back to 2 gigabytes. So there must have been an issue, and Workload Analytics is already notifying us about that potential issue by telling us there's abnormal data input. You can go through all the different stages of the job and find out how it performed. It's also interesting to have a look at the baseline tab. After a few runs of a job, we will establish a baseline, and you will always see the difference of your last or current run from that baseline. And that also helps you to quickly identify any potential issues or jobs that might be not working as expected. And then finally, there's also a view of the trends where we can see the duration of the job, and we can also see the data input and the data output. And then we also get a view of all the individual executions of that job. So that gives you a really great overview about everything that happened with that job. Let's just check on our job that we submitted. So that is still running at the moment, and it should be finished in a bit. So while this is running, we can also have a look at how you would actually connect third-party BI systems to an Altus data warehouse cluster. So when you go to your cluster, this is the cluster that we're using, and you display the access information. This is what you can use to just connect software like Tableau to your cluster. And I already did that before. So this is Tableau being connected to our Altus data warehouse cluster, and it shows us the busiest months for certain drop-off locations in New York that we selected using this map view. So this is a great possibility to give data analysts access to the data with their favorite tools. And it's just setting up a connection, ODBC or JDBC connection, and that's all. Let's check back one more time on our job. So our job completed. All I have to do in here now is to do a refresh of my metadata. So we will see the new tables that were created. I have to obviously go into the right database, refresh the database. And now we also see this new table summarized by drop-off zone, which I created using a completely different cluster, but because they're connected to the same SDX namespace, it's very easy for different clusters to share the data. So I'm just going to do a select from that drop-off zone to see the busiest drop-off zone, and that may be a good location for our billboard campaign to promote our new restaurants. So again, this query now directly going against Azure Data Lake Store, and here's the result. I can also quickly do a visual diagram here, just select the total trips, maybe look at the 10 most frequent locations, and here we go. So with those bars here, great opportunity to quickly visualize your data, but then obviously there's always tools like Tableau for the full visualization story. So with that, I think we've seen how we can analyze data quickly with Altus Data Warehouse. We can do ETL jobs with Altus Data Engineering. We can do workload troubleshooting, and all of that comes together by the use of Altus SDX and those namespaces that we talked about. So with that, I'd like to hand it over to Robert to talk more about the Data Integration Hub and how they're leveraging Cloudera Altus for their solution.
Okay, thanks, Michael. So, Data Intelligence Hub is a new T-Systems product that is going to be launched mid of September. So we are just before or prior to the launch and finishing on the last steps on our roadmap, cleaning up on the testing, etc. And Data Intelligence Hub has very early on strategically decided to leverage Cloudera Altus for a specific reason. But before we get there, I would like to give you a brief introduction into what Data Intelligence Hub is and what it was made for. So my name is Robert. I'm typically presenting together with Sven. Sven has done so many talks already, so he asked me to do this talk today. Sven is obviously the product manager of the Data Intelligence Hub. And I'm the architect for most parts of the Data Intelligence Hub with some years of experience in the Hadoop zone. So what is the Data Intelligence Hub? The Data Intelligence Hub is the first IoT marketplace that was built for all analytics matters, including secure data exchange between companies and enabling data-driven product and service innovations. And obviously, we care a lot about data ownership, data control, and data usage. Data Intelligence Hub comes with basically three major value propositions. We've got our data providers or our data owners on the left-hand side. Could be any entity, any company that is interested in sharing data on a marketplace, on monetizing their own data on a data marketplace. On the right-hand side, we've got the data consumers, which might even be things, which again might be companies who are interested in working with the data that is being shared on the Data Intelligence Hub. So data is our bottom line value proposition, or let's say sharing the data. And what Data Intelligence Hub also does is gives you the right tooling for processing the data. We call this the analytics toolkit and workbench for generating so-called insights from the data. that reside inside Data Intelligence Hub. And you can monetize on all three of those layers: on data, on analytics, and on tools. We are searching for partners who want to integrate their tools with Data Intelligence Hub. Cloudera is obviously one of our most strategic partners who have integrated their tools in Data Intelligence Hub. When we started thinking about the architecture of Data Intelligence Hub, we had a series of, I would call them challenges or considerations that we had to do. There was the option to set on top of a scalable infrastructure, let's call this a cloud, or we could have used an on-premise Hadoop cluster infrastructure that is more or less static, not being able to scale in and scale out. And we were comparing those two approaches with each other, and finally came to the conclusion that we want to go with an elastic cloud infrastructure. And the reasons for this were the following. We, as a marketplace that also offers tooling, analytics tooling to our customers, are interested in keeping our resource footprint small. So we do not want to provision a lot of resources that are not needed, because that would ultimately affect our pricing. We want to stay as lean as possible, and therefore we basically need an infrastructure that allows us to provision capacity, compute capacity on demand when it is needed and not upfront. Also, since we're talking about a common platform, we had to think about resource provisioning for heterogeneous workloads. Talking about transient workloads, there might be, for example, a small Spark job by one customer who's trying to analyze a couple of 100 gigabytes, and there might be this massive Hive script that is running over terabytes of data with different storage access patterns, etc. And we had to get all these different workloads under one common umbrella. We want to be able to provide for ad hoc scalability. So some customers of Data Intelligence Hub might be wanting to run a 3-node clusters, and some want to be able to scale out instantaneously to a couple of 100 nodes. And we can do this since we are based on Cloudera Altus. Security, of course, of an internet exposed large system is always critical and difficult to deal with. So who has worked with Hadoop knows how many interfaces Hadoop and Cloudera are exposing, and making them secure on the internet is a little bit difficult, a little bit challenging. Not impossible, but you really need to know what you do. Same is true for troubleshooting and failure analysis, for operating and administrating a heavily utilized system. And finally, we want to be able to bill our tenants as they go, right? These reasons brought us to building the Data Intelligence Hub on top of a public cloud infrastructure and using a Hadoop provisioning service that would allow us for instantaneously provisioning clusters. And that was, in that case, Altus. Why is that interesting to have the capacity or the capability to provision clusters on demand for a short amount of time and let them go away again? When you have a look at the workloads on your cluster, you will find out that there are workloads like, for example, streaming workloads that require a certain window of baseline capacity all the time. If you have a Spark streaming job, you will not be able to easily scale in or scale out the Spark streaming job, because it's basically binding to a set of Kafka partitions and it's consuming data from there. But the data that is ingested or processed by the streaming jobs might need to be processed in a batch fashion once a night, for example. And this is the rectangle you can see here, the overlapping rectangle. So we've got two workloads that are overlapping. We've got our streaming workload, which we obviously cannot change. You need this capacity all the time. But you have your batch workload that requires quite some big capacity for a short amount of time. And instead of provisioning for the discrete max capacity, which is basically your cluster sizing, the dashed line on top here, we actually want to provision the capacity when it is required, which is the solid line. And this gives us major benefits and cost savings, obviously. So basically, if you do the math, the gray area is the money you waste when you try to solve your transient big data workloads with an on-premise cluster. And this is the money that we would need to bill our customers, or on the other hand, which we are able to save them by using Cloudera Altus. Data Intelligence Hub, just as Michael showed before, is also building on top of Microsoft Azure. We are heavily utilizing Azure Data Lake Store, which you can see on the right-hand side. And Cloudera Altus is providing an excellent integration layer that is called an API, which you can code against the front end that you've seen from Michael. The graphical user interface, basically the web console, is consuming this web API or the Altus backend. And you, as a system integrator or as somebody who wants to build products based on Altus, can do just the same as we did. Code against the APIs, build your own stuff on top of it, and make Altus be your infrastructure bottom line. It comes with all the security with job curing, etc. But Michael has went through this already. I think at this point in time, you're a little bit more interested in what the Data Intelligence Hub is and how it looks. We can have a quick look into the sneak preview beta version that is currently under test. It's not yet launched, so please be patient. If you're interested, feel free to shoot us an email. But for now, it's not yet publicly deployed. So Data Intelligence Hub is a marketplace, as I tried to say. You can see offers, data offers that are listed here. That is, for example, look at this autonomous driving data offer. There's a description on the data set that is available, and we will have 90,000 data sets available on the 17th of September instantaneously. Public data sets, you can check them out for free. You can work with them for free. It's all for free. There's a description. There's for every data set a sample data view where you can check out the structure of the data set you might be interested in. There are certain specific views like this map view. The data set has a latitude, for example, and a longitude. You can use this map view to get like a preview on the data set. It comes with some charting on other features of the data set for you to acquaint yourself with the data set before you decide to check it out into a workspace, to subscribe to the data set, get it into what we call your tenant. So Data Intelligence Hub as well is a multi-tenant environment, and start working with it. And there's several tooling that you will be able to choose from Data Intelligence Hub to work with it, especially for the heavy workloads, for the big data workloads. We will go with Cloudera Altus. We did the integration effort. This is like an alpha version of our Altus support on Data Intelligence Hub. We will provision those clusters on a per tenant basis. So every tenant will have his own Altus cluster and can very easily deploy his own cluster or submit jobs. So basically what I can do here is do just exactly the same as Michael did. Create a new cluster. I can choose my Spark version. I'm targeting CDH 514. I need to target an environment. This is something Michael has not shown, I believe, which is a configuration in Azure, which we are creating for you. You can choose your instance types, which Michael did also, your number of nodes. I need my public SSH key. Like direct input, and I hit the create button. And if I check out clusters now, you will see that there's my new cluster being provisioned. It takes a while, to be fair. It takes a few minutes until the cluster is available. And I can also move over to the Altus console of Data Intelligence Hub, which Michael actually just did, and you'll see that it's very similar what's happening in here. If you're a user of Data Intelligence Hub, you've ingested a lot of data, or you're interested in bringing open data sets from European data sets, for example, together, joining them, analyzing them, or creating a data-driven app and add this to your production systems, you can submit a Spark job. Let's call this, I need to sneak peek a little bit. Let's call this a test Spark job. It's asking for the main class. The jar of the Spark job needs to reside in Azure Data Lake Store. So you need to copy it actually into your Data Intelligence Hub data store. We need to add some application arguments, and these application arguments are especially the input folder of which holds the data that my Spark job is going to process, the output folder in my Data Intelligence Hub environment, and I can click interrupt the job queue. So my other cluster that I just provisioned is still provisioning, and for that purpose, I will take an existing cluster. We say attach this Spark job to my cluster, and my job will start running. You basically saw the same thing in Michael's demo already. It's going to pop up in our Altus console again, and it's basically running and processing the data. So in Data Intelligence Hub, you've got your own storage account. As you saw, this is backed by Azure Data Lake Store. You can upload things here, and we're currently processing this file. I could be adding new data sets here, etc. Data Intelligence Hub will be launched on the 17th of September. What you saw currently, excluding Cloudera Altus, is for free. We have a freemium user concept where everybody who's interested can sign up to Data Intelligence Hub, can start uploading data sets, checking out one of the 90,000 data sets from our marketplace, and start playing around and processing with it. If you're interested in expanding your experience to also working with Altus, which we call Data Intelligence Hub Big Data Services, then you can give us a call and we can start talking to you about provisioning a premium tenant. All right. So this is basically the integration story of Cloudera Altus with Data Intelligence Hub that I want to show you. There is currently a public info page that you can access via dih.telecom.net to find out more about Data Intelligence Hub. You can also text us on what was our experience with integrating Cloudera Altus with Data Intelligence Hub. What is our roadmap? We are currently absorbing new features that are shipping, that will be shipping with Altus. We are member of the alpha program with Cloudera. We've been on board very early and would love your feedback, would love your questions. So far, so good. So, Michael, Raphael, I think it's time for questions from the audience. If we recorded any question?
Sure. Thank you so much, guys, for the presentation. So there's a couple of questions that popped in while you were presenting. So the first question is there a way to automate cluster creation and job submission?
Yes. Michael, do you want to address the question? Should I? Is it for?
You can take it, Robert.
Okay, yes. So the answer is basically ambivalent. It's true for Data Intelligence Hub as well as for Cloudera Altus. When you want to submit a new Spark job, you can create a new cluster that will only live as long as the Spark job runs, and it will be deprovisioned exactly when the Spark job has finished. So you can combine basically the submission of a Spark job with the creation of a cluster. We call this transient clusters. And the cool thing about it is that they really only live as long as the job runs and consume processing capacity from Azure as long as the job runs. They will stop causing cost afterwards.
All right.
Yep.
Yeah, there's a couple more questions, guys. So how can I try Cloudera Altus services?
I think there are two ways. So interested users could just register with a free trial for Cloudera Altus with Cloudera, but then they don't get the additional features that the DIH from Deutsche Telekom would provide them with. So they can just sign up for that. I think best way is to Google Cloudera Altus trial, then that should come up and they can register. Or as Robert said, they can also try out the DIH and then contact Robert and the team about trying out basically
Absolutely.
the Altus offering in there.
Absolutely, yeah. If somebody's interested in doing Altus through Data Intelligence Hub, because we've got so many cool data sets, please don't hesitate to approach us. We will also help you with getting trial licenses from Cloudera and doing this via the Data Intelligence Hub.
All right, another question. How do the Altus clusters authenticate against object stores like S3 or ADLS?
Michael, you want to take this one?
Yeah, I can take that one. So usually how that works is any of the cloud providers provides an identity access model. In AWS, it's called IAM. On Azure, that is called MSI, Managed Service Identity. And you use those identities, or you give those identities access to specific data in your object store, and then you assign those identities to clusters that you create. And that's how they automatically get access to the data sets in the object stores.
Okay, there's one more question, guys. How do I work with data as a Python/R developer in Cloudera Altus?
So in Altus, you can submit a PySpark job, basically the same as with an on-premise cluster. Just submit a PySpark job the same way I submitted my Scala-based Spark job, what you see before. With R, Michael, do you know more about R?
I think so. Really, with the job submission, currently we can't do that. So PySpark is the only way to do that at the moment. But then we could use Altus Director, as I showed before in my slide deck, to also provision a data science workbench environment where then data scientists can really work interactively with the data. And a great use case for Altus data engineering, for example, is model training at scale, where you have a Spark job, PySpark, or use Sparkly R or something like that, and you want to execute that. Use Altus data engineering for that, but then your actual model development happens in the data science workbench that's provisioned by Altus Director.
All right, it looks like we don't have any further questions from the audience. So unless Michael or Robert, you wanna add some more details?
No, I think what's left for me is to encourage the audience to check out Data Intelligence Hub. Freemium user, as I said, it's for free. Sign up when we are released. If you're interested already, shoot us an email. We will, on the first day of the release, provision you with a user. We can help you with understanding Cloudera Altus. We can onboard you on our DIH big data service, which are powered by Altus. You will see how cool that is to bring up clusters on demand and how much cost that will save you. Michael, anything you want to
add? Hard to beat. No, go and check out Data Intelligence Hub or Cloudera Altus. Yeah, and thank you very much for your attention and checking out this webinar. Yeah, that's basically it. Just have fun trying out our solutions that you can try out for free.
All right. Thank you so much, guys. Thank you, everyone, for joining. For those of you who joined later during the session, today's session is going to be recorded, and we're going to send out the URL to the recording within the next 48 hours. So thank you again. Have a great day. Have a great evening, depending on the time zone. and see you next time.
Thank you. Bye-bye.
Thank you, everyone.